Hello and welcome to another episode on Mindful Journey. Today, we delve into the fascinating world of earthquakes and how they shape our planet. Earthquakes, a phenomenon as old as the Earth itself, are a natural part of our planet's life cycle. They're the Earth's way of releasing stress, much like a pressure cooker letting off steam. This seemingly destructive force is, in reality, a crucial factor that has shaped our world and continues to do so every day. Why do earthquakes happen, you ask? At the heart of it all are tectonic plates, these massive slabs of rock beneath us that are constantly on the move. When these plates interact, it results in the ground shaking, sometimes subtly, at other times with devastating impact. The process is intricate, complex, yet absolutely compelling. So are you curious to know why the ground beneath us sometimes shakes? Stay with us as we unravel the mystery. To understand earthquakes, we first need to understand the Earth's structure. Picture our planet not as a solid sphere, but as a series of layers, each with their own unique characteristics. The outermost layer, the one we live on, is called the crust. It's a relatively thin layer, ranging from 5 to 70 kilometers thick, depending on whether you're under the ocean or on a mountain peak. Now, the crust isn't a single, unbroken shell. It's more like a jigsaw puzzle. It's broken into several pieces or plates, which we call tectonic plates. There are 7 major tectonic plates, namely the African, Antarctic, Eurasian, North American, South American, India, Australian, and Pacific plates. These plates aren't static. They're constantly shifting and moving, albeit at a pace slower than the growth of our fingernails. Why do these plates move? Well, they're not exactly floating on water. Instead, they're resting on a hotter and softer layer of Earth called the asthenosphere. It's this layer that allows for the movement of the tectonic plates. Picture it like a pot of soup. The soup gets heated at the bottom, rises to the top, cools, and then sinks back down, creating a circular motion. Similarly, the Earth's asthenosphere is continually heated by the core, causing it to rise, cool, and sink back down. This constant cyclical motion is what nudges and pushes the tectonic plates around. When these plates collide, pull apart, or slide past one another, the Earth's crust is deformed and broken in the process, leading to what we know as earthquakes. So, in essence, the Earth's crust is not a placid, unchanging surface. It's a dynamic, ever-moving jigsaw puzzle, driven by the heat from deep within the Earth. And it's this ceaseless movement that makes our planet a vibrant, ever-changing place to live. It is the movement of these tectonic plates that leads to earthquakes. But what causes these plates to move? Let's find out. The tectonic plates do not move on their own. They are driven by a process known as convection currents. This process is a natural phenomenon that occurs within the Earth's mantle, the layer between the crust and the core. Picture a pot of water on a stove. As you heat the water from below, it becomes less dense, causing it to rise to the top. Once it reaches the top, it cools down, becomes denser, and then sinks back to the bottom. This cycle repeats, creating a circular motion. This is a simplified example of a convection current. Now, let's apply this concept to the Earth's mantle. The mantle is composed of semi-molten rock, not water, but the principle is the same. The Earth's core is like our stove, radiating heat. This heat warms up the rock in the lower mantle, reducing its density so it rises upwards. As it nears the crust, the rock cools, becomes denser, and then sinks back down, creating a continuous cycle. These are the convection currents in the Earth's mantle. These currents are not as simple or as peaceful as our pot of water example. They are incredibly powerful, capable of moving the massive tectonic plates that make up the Earth's crust. Imagine the force it takes to move continents. The tectonic plates float on the semi-molten rock of the mantle, much like a raft on a river. And just as a raft is carried by the current of a river, the tectonic plates are moved by these convection currents. When these plates interact, they can cause earthquakes. For example, when 2 plates collide, one can be forced beneath the other, a process called subduction. The intense pressure and heat can cause the crust to crack and break, resulting in an earthquake. In essence, the Earth's dynamic nature, the constant movement and interaction of its tectonic plates, is all driven by these convection currents. These convection currents, therefore, are the driving force behind the movement of tectonic plates and the resulting earthquakes. Now that we know what drives the tectonic plates, we can understand how earthquakes occur. Earthquakes, in essence, are the Earth's natural means of releasing stress. As the tectonic plates move, they sometimes get stuck at their edges due to friction. When the force of the moving plates exceeds the force of friction, the plates slip, causing the ground to shake. This shaking is what we feel during an earthquake. Imagine this scenario. You're trying to push a heavy object, but it's stuck. You push and push until finally it moves. That sudden movement is similar to what happens during an earthquake. The tectonic plates are the heavy object, and the Earth's crust is the surface it's stuck on. When the plates finally slip, that's when we feel the ground shake. This release of energy travels in waves called seismic waves, radiating out from the point where the earthquake originated, known as the epicenter. These waves can travel great distances, shaking the ground as they go. The severity of an earthquake can vary greatly, from ones that are barely felt to those that can cause significant damage. And there you have it. From the movement of tectonic plates to the release of seismic waves, these processes culminate in what we know as an earthquake. It's a fascinating, albeit sometimes frightening, display of the immense power and dynamism of our planet. So, that's how an earthquake occurs. Fascinating, isn't it? Let's quickly recap what we've learned today. We've journeyed into the depths of our planet, understanding how the Earth's structure and tectonic plates play a crucial role in causing earthquakes. We've explored the fascinating concept of convection currents and how these plate movements result in seismic activities. Our understanding of these natural phenomena is key to safeguarding our world. Thank you for joining us today on Mindful Journey. Remember, understanding our world is the first step toward protecting it. We'll see you next time with another interesting topic. Until then, stay curious and keep learning.